Hmm? You gotta, where? I don't even. What'd you do? Oh, you don't use Chrome.
Okay.
Yeah. So, right. Yeah. If you use Safari, you can open in preview with a click. If you use Chrome, then right. So actually, I have the initial chair slides right here. Do you want me to project the chair slides real quick, and then I can close that out. Don't need social media. Oh, that's. All right. Good morning, everyone. Welcome to IPPM, IP Performance Metrics. I'm Brian Trammell. This is Bill Cervani. We are your humble co-chairs. This is an IETF working group meeting. The note well applies. Anything said here is a contribution to the IETF. All IETF contributions are subject to the rules of 5378 and 8179. Usually at this point I say probably by Wednesday you should have seen this at least once. If you haven't seen this, then actually read it to understand what's going on. I'm going to draw attention to the fact that the RFC number for IPR disclosures has changed. That's because the policy has actually changed somewhat, so please do make sure you have a look at 8179 and understand what it says. Here is what we think the status of our working group drafts is. I would be happy to be corrected by any of the authors if we have this wrong. I'm pretty sure that RFC 8186 was in fact published because I know what the RFC number is, so yay. Another IPPM RFC. We have a 11 rev of model-based metrics that was updated just before the meeting. I believe this is ready for ballot, Al? Okay, so is it scheduled on the telechat yet? Okay, cool. So that's just happening. So that draft came in on our original recharter in Orlando, IETF 86 in March of 2013. So it turned out to have been somewhat more complicated journey than we thought it was going to be, although in hindsight, we probably should have seen it coming because it actually turns out that bulk transfer capacity measurement on a real network is hard. We have 6-man PDM option 13, which is completing IESG evaluation, or is it through at this point? It's through. Okay, so hey, we have two that are basically on their way out. 2330 IPv601, we're going to have a talk about. My understanding is we're still waiting on 6-man. So we're not waiting as much on 6-man because the internet standard has been published. There are continuing discussions about addressing architectures that will terminate at some point before the heat death of the universe. We've got Altmark 05, working group last call is complete, and we're waiting for a write-up from the Shepherd. Thank you, Carlos. Thank you very much. We are going to start the working group last call on TWAMP Yang during this meeting. Basically, I'm going to send that email out to the list as soon as I'm not projecting these slides. Any volunteers for Shepherds, people who've been following the Yang model for TWAMP, who would like to help us out in writing the Shepherd statement. So the Shepherd statement is essentially a statement that goes up to the IESG. It says, here's how the working group process worked out. Here's, I've actually checked all the IPR disclosures that have been made have been made. This is a report of how things were at the working group level, and it helps the IESG do their evaluation. So it's not an enormous amount of work, and it is sort of a good way to get some experience with, the depth of the process that we use here at the IETF. So any volunteers to shepherd that document through? We'll take that call to the list. Metric registry and initial registry, 12 and 4. This is another one that we actually probably we knew that this was going to take as long as it was going to take. One of the things that we chased down in discussions about this draft, I believe in Chicago, but it might have been Seoul, was we really need to have some metrics and measurement and representation methodologies for information about a path that is discovered through active measurement. And I think Al is going to present that draft, or is Ignacio? Ignacio is presenting the draft. Okay. Excellent. So that's where we are with the drafts. Here's our agenda. We're going to start with initial metric registry from Al, and then we're going to have 2330 IPv6 from Joachim. Then we have basically two larger discussions on the agenda. One is a rechartering discussion, which we'll come back to. We have some slides introducing that and going into the details of the charters. There will be a bit of a charter bashing session. The thing that raised this issue was the discussion in Chicago about bringing the in situ OEM work into IPPM. But it turns out that actually most of the changes that we want to make to the charter are about reflecting work that we're already doing, or that we've realized in the course of the past 4 years that we need to do. So there are a couple of presentations that are related to this. So all of the IOEM stuff, so the updates in the IOEM stuff we'll have as part of that discussion. And then also the route metrics draft that Ignacio will bring in. After that, we're going to talk about TWAMP Lite, presentation from Al, 2 presentations from Greg, and a discussion afterward about, so what this is basically about is the Broadband Forum would like to be able to use the TWAMP test protocol on its own, and needs a registered port for it. So that seems like a good time to basically clear up remaining ambiguity about the status of that as a protocol. And I think we can come to, I might be optimistic here, but I think we can come to some sort of consensus in about 20 minutes on that. After that, we have 6 lightning talks. We have probably, if we do the agenda in the order that we have it, I think we have, we might actually have time for 6 now because we took 15 minutes back out of the agenda. So these are work that has not been discussed on list, but may be of interest to the IPPM community. These are ordered basically in order of first things that are directly applicable to continuing working group work. So there's a couple on alternate marking. Then new work that we have not yet seen in order of request timestamp. And then returning work that is not directly related to other work in the working group. So this is the queue. And we'll go through those 5 minutes at a time. I'd like to try something. I'm not sure we've done this in IPPM before. So there's a 5-minute limit. When we hit the 5-minute limit, we're all going to clap and thank the author until they sit down. So with that, we will go to Al on the registry and swap over.
Okay, registry for performance metrics. Good morning, everybody. Nice full room today. So I'm Al Morton, and doing this with Marcelo, Benoit, and Phil, and Amr. Next slide. So we a long time ago decided that we needed to specify metrics with more precision than we did with the flexible versions that we put in the RFCs. And you know, you can read this quickly while I'm talking here, but we really need to narrow these things down because we want to make clear comparisons between the systems that we measure, and that's only possible if a lot of things are documented and everybody refers to the detailed implementations and discussion that we've got here. So obviously with a registry, you provide a unique ID and detailed exposition and all sorts of things. So we're trying to raise the bar on what it means to measure delay, what it means to measure loss in very specific circumstances. Next slide. Oh, is there a clicker? There's a clicker. Oh, what's this? Right, let's just try it. Yeah, that's good. Okay. So we've got a registry concept, and we've been working on this for a long time. And we think now that with the Buenos Aires naming scheme and all sorts of things that we've done, we're actually getting pretty close to what we need. So also had lots of good meetings with the IANA folks, because if you've ever looked at the IANA directories and registries, they typically display things about a screen wide. And if it goes beyond sort of a screen width, it becomes a very complicated thing. And if you ask them to do the review and not help them out with experts, that can be difficult too. So we're actually kind of minimizing what we ask of IANA in this, and we're going to support that with the additional detailed information. So as you can see, this is organized in categories and columns. We've got summary columns, metric definition. Actually, the categories are here on the left. And lots of detail has to be added here so that we really nail down what the implementations have to do in order to make these measurements. Okay, so we may come back to that. So we added a lot of new loss metrics this time around in the initial contents, and that yielded feedback on the names. So down here in the bottom, the IANA section talks about three things that we're asking them to do. We're asking them to give us URI namespace, as indicated there, and to help us with a sub-registry of the name types and the elements of each name that feed into the names. So what did we do with that? Let's see here. Is this a good place to go through that? No, actually, so on one of the next drafts, I'll talk about that some more. But we've got the name elements divided up into these categories: the metric type, the method, the subtype method. You'll see how that works, and the subtypes can be expanded so that you can be as expository as possible. The reference specification for this metric row, the measurement units, and the output formats. So the third item in the IANA section is all about the instructions for adding the new registry entries, and to recognize the extension of the metric registry in at least one category. And each entry will be mocked up, and I've been working on the mock-ups so that IANA essentially knows as much as possible what to do. And I don't expect you to read all the little text here, but I did try to make the names as big as possible. So you can see that the very first metric is a round-trip delay, RT delay metric. It's active method. The subtype methods are IP, UDP, and Poisson. The RC number will be filled out. The units of measure are seconds, and the actual metric is 95th percentile. It's all pretty easy to figure out from the name, but we've got a description there too. And one key point is that under the URI column, and you can't see all the columns here that IANA will produce, but one key thing there is that there will be a URL to the complete registry description, which wouldn't work in a in a screen kind of thing like this. You basically want to be able to see all the information, read it like a document, and that's what the URL will point to. Okay, so here are the new name elements that we came up with as a result of this adding loss. And so we've got effectively a new category here, the response loss for domain name service queries. We revised the units so that we have ratio, which is unitless, and then percent, which can be used for many different things, but now that can be added to a ratio if necessary. And we also have logical, which is 1, 0. I think that could also be true, false, in fact, and that's one of the things in my mind to change here if we get a chance. So, and on the outputs, we have singleton, which is just a single sort of single number output. And that's now distinguished from raw, which is multiple singletons. That's the way these things were always mentioned. So we're going to have both singleton and raw, and we've now explicitly got this loss ratio in there, which is loss to total packets, usually less than or equal to 1. All right, so here's the mock-up of the name element sub-registry. These are all for metric type, and these are the ones, this is a subset of the ones that we have there now for round-trip delay, for round-trip response time for the DNS, response loss for DNS, one-way delay, round-trip loss. There's a whole bunch more in this first category of metric type. And you'll actually see more columns off to the right there as well when you see the final version. Okay, so the question we've been asking, and for anybody who does true passive measurement, do the name element sets cover passive well enough? And I think if someone actually doing passive measurement was to take a look at this, they might have some ideas for us. But that doesn't seem to be the kind of feedback forthcoming. And every time we look at this and add a few metrics or whatever, it's been a chance to add new name elements. And we've done that. And so it's fairly easy to do this in the future. And I think that's our protection. If we don't get this feedback, we'll be okay. So how am I doing on time? All right. So here's the initial performance metric registry entries. These are the actual detailed entries that we're going to propose right away to put in. And you can see there's a long history of drafts here. Four co-authors, Marcelo, Phil, and Kevin D'Souza, my colleague at AT&T. So the feedback on the registry contents. We're actually, still seeking what folks would like to see if they go ahead and look at this stuff hard, these detailed registry contents, and appreciate what it takes to implement these metrics. We've had regulator guests in the past. That's what Regu guests stands for, and actually over the last 3 or 4 meetings in a row. Probably not this time, but we'd like people to feed into this. So now, sections 4 through 8 in this draft introduce all the new detailed registry contents. And what we found this time around was that it was fairly easy to add a loss metric kind of like as an overlay or a subsection in each one of the ones where, for example, if we had round-trip delay before with UDP, the first metric I mentioned, it was fairly easy to add loss. And that's because the methodologies are so closely related. With loss and delay, you use a timeout to determine whether the packet's lost or delayed, or you're just not going to wait for it anymore. And because of that commonality of the methodologies, fairly easy to put in loss. So now in the draft, we have many questions that were sort of answered and decided with short discussions. And based on the IANA work to clarify the protocols, we've got the ability to for editors like me to expand our list of metrics, and to do that economically by having an approach where one section can actually create the registry entries for let's say 4 or 5 all delay related metrics and loss, as I said, because they're very closely related. So we've applied that approach now to almost all the sections, so the early sections and the later sections, 7 and 8. So here are the new metrics, and now you can look at some more names in a little bit larger font size. As I mentioned, and these are all going to be loss related, obviously. So we've got round trip loss, active, IP, UDP, the response loss for DNS, one-way loss for active IP, UDP Poisson, and one-way loss for IP, UDP periodic, and the rest of the information there. Anybody need the blue sheets? Actually, I do, Spencer.
Anywhere else.
I know. Well, I guess I stood up at the wrong time. Thank you. Okay, so so I said loss has been added in the absolute simplest way. We've got this trace route metric proposed. We'll be discussing that at the meeting here, and I think this is worthwhile adding. maybe we don't need to do it as part of the initial contents. Maybe we can do it as an adder or something like that, but we'll let the working group decide that. There's many methods of measurement, though. That's the interesting part, and that's what we, there's some new work going on in that area, and there's always research in the area of traceroute, both the active and the hybrid methods of measurement. So here's a question to the group. In the past, folks have said, yeah, we'd like to have a registered metric for ICMP echo request, echo reply. But, and it's a big but here, is anybody going to really use this as a basis for comparison between systems? And is anybody going to use a ping measurement for regulatory compliance? And I'm kind of thinking maybe not, but Brian's going to say something.
Brian Trammell, you would be surprised and horrified.
Every day.
Yeah, no, I mean, so in a lot of measurement situations, especially so like there's this, there's a broadband measurement project, I guess. So it's broadband mapping project that the commission is running, the European Commission is running for regulatory use cases primarily. And their latency metrics, I think, they haven't really decided what they're going to use, but it's going to be whatever they have in the data set from the active measurement provider. And in a whole lot of cases, that's ping. So I think we need this. Well, and because, I mean, if you're actually looking for, again, it's back down to do you want to look at the difference between 53 and 55 milliseconds? Which actually you can, if it's stable, ping will, you can do a bunch of math and you get, or do you want to look at the difference between 10 and 1,000 milliseconds? And ping's okay for between 10 and 1,000 milliseconds.
Yeah.
Okay. So it's really down to so I think we really actually do need this.
But I guess the point,
because people are going to use it.
Yeah. All right. Well, if people are really going to use it and regulators are going to ask for it, then we're stuck with it.
I think we'd like to nudge them in the direction of using measurement methodologies that are slightly more comparable. But
and one way to do that is to not include it.
I don't think that's going to be a nudge that works, Al.
Okay.
Because if that's all they have, right? There's two things that you can do. You can either pretend that you used TWAMP. You use ping and you say, oh, we use TWAMP for this, which is terrible. Or you don't use the system, which doesn't actually give us the comparability that we want. So I think that we kind of need to. So there was a second question that you asked earlier in the previous. You don't have to go back to it. Okay. Is this okay? Actually, no. Show me the update, the metrics. Just show me the names.
Yeah.
For passive measurement, there's basically two that you can easily use. I mean, there's a whole bunch of various bits of TCP passive measurement looking at transport level performance characteristics, right? Which is latency loss jitter.
Yeah.
The jitter definitions you can get out of that are going to be subtly incompatible with the jitter definition that we have in our metrics,
right? Simply
because of the way that TCP works. There's also some discussion in the Quick working group about what should the measurability aspects of Quick be.
Right.
And most of the work there is focusing on RTT, end-to-end RTT.
Okay.
And a lot of the work, there's been informal surveys of who ships boxes that do what. And a lot of the work that I've seen as part of that effort for figuring out what Quick should do based on what people are already doing with passive measurement and operations is that RTT is king. Loss is taken to be interesting, but is much less interesting than RTT. Latency is because you can guess. You can do active measurements if you're in a troubleshooting situation with loss, but doing active measurements on the same path with the same traffic with the same headers to get exactly the same network treatment, passive is the only way to do it.
Yeah.
So I think the exercise is you take these are all of the, so this would be RLDN. No, these are the loss metrics, right? So we basically go, there's
a delay comparable version to this.
Right. Well, because so RTT, TCP RTT, there's not a delay comparable loss metric for TCP RTT, just because of the very nature of it.
Right.
But I think that the exercise is basically taking just the delay metrics for UDP and then reframing them as TCP RTT. Passive.
Yeah. So I mean, I can see this happening in the names pretty easily.
Yeah, right.
Get rid of what's on here.
And then writing the definition to be, do the stupid thing, right?
Yeah.
Which is watch the packet, match it with another packet.
Yeah.
It's not. I have text that I've written like 6 times explaining that we could,
It must be good by now.
munch. That you could munch together and so I can actually ping me on that and I can actually contribute.
All right,
to that.
cool.
But it looks to me, I mean, do I do a lot of passive measurement in operations right now? No. Do I think a lot about it? Yes. And then this looks to me to be fine, right? So.
All right.
Thanks.
Sure thing. Thank you. Mike
Ackerman. Good stuff as usual. Thank you. My comment is on your ICMP question.
Yeah.
And in enterprises, we use that a lot for both latency and loss. And so I'd like to see it included or retained or whatever.
Well, we're not precluding people from doing it. It's for the registry. It's
Right.
really, for me, it's really about these comparisons.
We're going to do it
compare-
anyway. If it's in the registry, then that gives us
All right.
a whole thing. And I have one other dumb question while I'm up here on the response time loss or the response loss for DNS.
Yeah.
What is that actually telling me? Is that there was a request to which there was no reply?
Man, you have set me up perfectly.
Oh, okay.
Look at this.
I've done my job. I'm going.
So no, stand right there. I mean, in DNS response time measurement, if you get the response you wanted or the query answer, then you're good. But we have these 2 possible methodologies for measuring loss. We could require support of an ID generation and population in the message, so that when you get another message back from a second query, you know which one it was. It resolves ambiguity. An alternative would be to use a random source port. What the hell just happened?
I just took his closest one. You're fine. I just,
You closed the presentation mode. Yeah. All right. So, but what we would choose one method.
That's his version of clapping.
Yeah, I think so. That's. I mean, he wasn't willing to own up to it, but I think that's.
He's real subtle.
I think that's right. So this is a major question we need to answer here in the context of DNS loss. Do we want to use this random source port methodology, or do we want to impose on people to insert a sequence number somehow? And that's.
I hope I didn't stay here to give you that answer.
No.
I'd like to work with you on that if you'd like.
All right. Well, let's let's talk about it.
Leaning towards the first.
I think we're actually running out of time, but this was the major question I wanted to ask here. And also, I think we're going to convert a couple of the metrics in Section 4 and Section 5 to periodic instead. That seems to be the actual implementation. So that's what I think we'll go for. Make it really quick, Nalini. I'm over time here. Sorry.
Okay, real quick. Yeah, there's actually already is an ID in the transaction ID, the Nalini Elkins in the DNS, but DNS is going to be encrypted, so we're going to lose it.
Yeah, great. Well, but the problem is it may not be populated. I think that's the problem. Let's talk. That's why I raised the question. Let's nail that down. All right. So thanks very much, everybody. Geez, read the draft. If you're going to have to implement metrics, read the draft.
Who has read one of the last 3 revisions of the registry draft, or the last 2 revisions of the initial registry draft? Okay.
Like ghost authors.
Right. We encourage eyeballs on this. So, thank you.
Especially if you're going to build stuff. All right, here's the tools. Thank you.
So, hello, my name is Joachim Fabini. I'm co-authoring this with Al, Nalini, Mike, and Vin. This is about an update of the IP performance metrics framework for IP version 6. So a background, most of you probably know it already. So we have the IP performance metrics framework summarizes the basics on which we build metrics. So we have the basic traits there. We have some definitions. We have some assumptions about packets there. And so the result of measurements might depend in this case on packet types. In this, and unfortunately, the IP performance metrics framework was written back in 1998, if I remember correctly. So by this time, we didn't have IP version 6, or it was in the course of being standardized. So we have there a statement that says a packet must include a valid header and the version field is 4, meaning IP version 6 is out of scope. We have defined our metrics with IP version 6 in mind, but according to the IP performance metrics framework, it's out of scope. Any IP version 6 measurement. Good. We had some input of Brian Carpenter during a review, and we said we will fix it in an update. Good. It was adopted as a working group item back a year ago. And yes, had some work done on this. We had some input. Status at last IETF was that there is discussion needed and we need to wait. Finally, we had some working items, and we tried now to find solutions to no longer wait. In reply to your question, so and to have to find our assumptions, to find our way, and to propose solutions. And these are the solutions. So, first question was about fragmentation, IP version 6 fragmentation, which is commonly encountered. We have this quite distinct method of fragmentation, just the descending host and so on and so on. Everybody knows. And we thought about how to include IP version 6 fragments. And it turned out to be impossible, because if we, all metrics are built on the assumption that we do not have fragmentation. Meaning, if we introduce now allow fragmentation for IP version 6, it means we need to review and revisit all metric definitions, and also with respect to IP version 4, and that's not feasible. So this is, we adopt exactly the same approach that we have for IP version 4, and this is what we propose, and say IP version 6 fragments are out of scope. So if fragments are used, everyone's on his own in defining and finding the right scope for this measurement. Brian?
So, hi, Brian Trammell. I only see one problem with this, and this is all kind of hearsay. So is anybody working on 6-LoWPAN in the room?
6-LoWPAN is on the next slide. Sorry. But not on my laptop, please, yeah? Yeah, so, okay. 6-LoWPAN and IP version 6 header compression. So we did some maths, and it turns out, and also it's written also in the 6-LoWPAN, I spent some time on reading these 6-LoWPAN RFCs. It turns out that we have about 31 bytes of user data per packet. And in addition, we do not have any IP addresses, neither IP version 4 nor IP version 6 addresses in IP, except if we're tunneling. So this is if our packet fits into these 31 bytes, then we can use a kind of tunneling mode, just transfer plain IP version 6 packets over IP over 6-LoW, and so on and so on. So our impression was that doing 6-LoW and including 6-LoW here and allowing 6-LoW means that we have to revisit anything. That is, even the concepts of standard form packet do not fit. We need to review all of them. And this is definitely out of scope. So it is clear that we do not include this explicitly. The 6-LoW is out of scope. But we feel that it is better to have this, to have IP version 6 going on the right track, to have IP version 6 standardized. And if someone feels that is in need of a 6-LoW, then to do it in a separate document.
So, hi, Brian Trammell. This is the answer that I was hoping you get to. So the only place that it makes sense to have explicit support in the framework for 6-LoW, in my opinion, is if there is an interesting measurement application where you're comparing IPv6 to 6-low packets, or you're doing path composition metrics where you have a gateway that's actually doing some sort of algorithmic transform on the packets and making them turn into 6-low packets, which doesn't seem like, that seems like such a little corner case that I think that we can safely carve it off and say, if 6-low people want to use the framework, then please come and do the work to update it.
So real quick on that. Hi, Al Morton. I sort of assumed that there would be a gateway. You're imagining that 6-low packets get generated as 6-low packets, and only
on the upstream, if you're only
looking
at the part of the path between the gateway,
right. Then it's all 6-low. Yeah, but I guess I was looking at the end-to-end piece. No. Okay. All right.
Yeah. Good enough. I don't think that changed the answer to the question though. So thanks.
Spencer?
Spencer Dawkins. As a curious area director, I think that I have pretty good visibility of kind of where we are with 6-low and fragments here, but I'm not sure how aware the ROC community is about this situation. Do you think they know that that's going on, or?
No.
I know it's harder because there's not a working group, right?
I'm almost sure that they do not know. Perhaps they'll know now. We need some way to contact them. But in fact, so the problem that I see is really with this definition of a standard form packet that we try to fit to IP version 6 now to find solution to this. And having 16-bit or 16-bit addressing that is proprietary to 8.2.15.4 it creates some kind of difficulty, because we have the RFC. We try to stick as much as possible with the existing RFC, with the framework.
Sure.
And introducing now a distinct kind of addressing where we do not have all of these fields, payload length and whatsoever and so on, complicates matters.
Cool. I will take the action to go back and send an email to the relevant area directors now. So thank you for giving us clues.
Okay, thank you very much indeed. Good. So this was about 6-low. Robust header compression is alike. So we have state in the network. That's one more problem. We create state in the network in network nodes that also impair on the type P, that change the type P of packets. So it's somehow difficult, and we'll try to promote this fast to have IP version 6 included into our measurements. Good. We have this context, this concept of a minimal standard form packet, and it's said, the RFC says that it is often useful. I don't know of one single reference to this concept of a minimal standard form packet, and I don't know how it could be treated in practice, because this means that we basically do not have any payload, any transport layer headers in a packet. Perhaps in IP version 6 we could do it with a no next header field directly in the IP header, but I don't know to which extent this makes any sense. And for IP version 4, I don't know of any way how to specify that we do not have any transport header, because we didn't, and the protocols field must be left unspecified, moreover. So we opt for dropping this support. That's for discussion. Unless anybody's using it, right? Thank you, Al. So is anybody using the minimal standard formed header? Okay, thank you. Good. And last thing was the IP version 6 extension header treatment, and this might be a controversial discussion. We wanted to wait for 6man to find a conclusion. They haven't found it. And now with in situ OIM and all other aspects, we just said we increasingly see an encryption of higher layers. If we refer to QUIC, we see that transport layers are encrypted. We have no way of conveying OIM information timestamp and so over the network. So from the perspective of IP performance metrics, it does make sense to allow addition of extension headers on the path and removal of extension headers along the path. This is our position. We would like to have it. We do not know, and perhaps before the end of the universe we will know if it will be allowed or not allowed. But from an OAM perspective and IPPM perspective, we believe it should be allowed. We need it. we have some challenges. We need to define, and this is what we will do. So define also challenges. Adding an extension header. We seen on Saturday in the ANRW workshop, there was a discussion on segment routing. Obviously, adding a segment routing header somewhere along the path changes the route and therefore the type P of the packet. So there will be some need for discussion, but we feel that adding the extension headers, removing them, and even modifying them along the path could be helpful for our purpose. So the proposal is to allow this, and status and next steps. Thanks for updating the slide. Good. We have proposals for basically all of our open items. We want to have a discussion either on list or off list, and finally to reach a conclusion we will update the draft, and then we want to go working group plus call, and we want to do it soon. So integrating all of these items into the draft should take a matter of weeks, and perhaps we can do the working group plus call even before next IETF meeting.
All right, so this is a call for pre-working group last call comments. Okay.
Yes, please.
Who's read the draft? Okay, I can't see a whole lot of. I'm like hunched down over here. Like, okay, Mike, that doesn't count. Okay, cool. Again, encouraging eyeballs on this because we will. Let's see, working backward from November. We'll want to. Yeah, we'll want to do this sort of like early October at the latest. So actually, as soon as you guys get the next rev up, we'll start WGLC. Please nudge us on that. For that, we'll also need a document shepherd. Anybody in the room with IPv6 expertise? I see Jen Linkova hiding. I see Steven Stroh not looking at me. Huh? Did someone just nominate Nalini? Awesome.
She wasn't paying attention to say no.
Okay. Oh, wait, Nalini, yeah, Nalini's co-author. Yeah, we can't do that. Okay. Yeah, nice try. Michael's also a co-author, right?
Yeah.
Yeah, it's unfortunate. All right, so we will we will leave that as an open question for the working group last call, but please consider whether or not you could help out as shepherd on this.
Yeah, so
Thank you.
the problem is that existing RFCs depend on this draft becoming an RFC. So,
Mike Ackerman, a quick question on the previous slide about extension header processing. Well, Kim, you articulated it perfectly. My question is, what's the next step relative to that? Do we want to carry this opinion? Well, first off, is it the opinion of IPPM? Secondly, do we carry that forward to 6-man is my question, or is this a premature question on my part?
difficult to answer.
I don't actually, there's not any impact on V6. So this is not a 6-man thing, right? This is an impact on our framework.
It basically is an impact of the handling on the handling of extension headers, and they're pretty religious about this, as far as I heard from different meetings.
We cross Al Morton's suggests we cross post the last call. Yeah.
Right, we cross post the last call, but this is not a thing that there's not 6-man work that depends on this, correct?
I don't think so. No.
This is the issue that 6-man is debating whether.
Right.
Okay.
Right.
And I
So we
was
should
wondering,
absolutely-
would they like the benefit of our input, so to speak?
Certainly.
That's what I thought.
Yeah, no, so okay, yeah, so we'll cross post actually when you like pre-WGLC, do cross post the announcement of the posting of the next thing. Cool.
Thank you.
Thank you. All right. Yeah, I'll do that. Yeah. Everybody awake? Yeah. Feel like rechartering a working group? Yeah. All right. So we've had our current charters for a little more than 4 years now. I wasn't actually expecting this charter to last this long. Yay, model-based metrics. There were questions in Chicago and post-Chicago about bringing IOEM into IPPM. There seemed to be rough working group consensus that work fits here. There seemed to be working group disagreement that work fits here under the current charter. So we decided that we'd have a discussion about the charter. So Bill and I actually sat down and opened this up. And when we opened it up, we actually found that it doesn't really optimally cover what we're doing now. It was worded in such a way that everything we're doing now technically kind of fits. And that was on purpose because we wanted to have a relatively wide charter to, be able to chase down sort of things that came out of the metric stuff, things that came out of the 2330 stuff that, we have a line in the charter that says we're going to update our framework, but not necessarily reacting to external things, but hey, it doesn't really matter. And the idea was let's make some small edits to catch up to the present. So we're going to go through these paragraph by paragraph. We only touch 4 paragraphs at the end. And it turns out that touching those paragraphs doesn't really change much normative language with respect to whether IOEM comes in. So the first thing we want to do is rename the working group. We've been called IP performance metrics since 1980 Mumble. If you look at the work on our agenda, we have, we're spending a little bit less than half our time on metrics and a little bit more than half our time on methodologies. And those methodologies are on charter for our working group in that they allow us to measure metrics, but it might actually be more useful to be explicit about the fact that we do measurement. This is, I'm sorry for the red, green, colorblind people. If it's bold, then it's new. If it's crossed out, then it goes away. I tried to have it so that it would actually work, but I'm seeing the bold might not actually be bold enough to point out that it's new. So strike metrics, replace with measurement. Then we take the sentences specifying network and lower layer OEM mechanisms out of scope for the IPPM charter. Now, when I look at what IOEM is, it's not a lower layer OEM mechanism. It's a mechanism for carrying certain information on path, which can be bound to lower layer headers, but it doesn't, like, the naming is unfortunate, but I think the naming is unfortunate as a collision between sort of ops area terminology and transport area terminology. Anything that looks kind of like measurement in ops, in my understanding, gets called OEM because it's a management function. In order to remove confusion here, we would suggest that we just strike this line. I don't think that striking this line is necessary to bring IOEM in, but on the other hand, we have a line that says we don't do OEM, and then we have a draft called IOEM. I can see how that can be confusing, right? And it's splitting hairs to say, well, so this is something that I think makes it clear, and I don't actually know what having this in solves. I don't know the problem that this line solves. And then basically the rest of the edits are, we add protocols and methodologies to the things that we do. It was a metrics heavy introductory paragraph. Now it's a metrics, protocols, and methodologies heavy intro paragraph. Again, this just reflects, you could say that this is editorial. This reflects sort of what we've been doing. Al had a suggestion that we strike and not a value judgment, because it could be somewhat confusing that the way that MBM works is you do an acceptance test, which looks kind of like a value judgment because yes and no are values. But it still does provide an unbiased quantitative performance measurement. And that was what we were really trying to get at with that text. And I think that this and not a value judgment, this is some of the oldest text in the charter, right? Are there any comments on paragraph 1? Spencer.
Spencer Dawkins, the responsible area director. I don't mind getting appeals. I mind getting appeals that include the words "can't you read?" So thank you for striking that sentence.
Hi, Tom Mizrahi Marvell. I apologize for this comment, but can we get rid of IP? Because some of the methodologies we're discussing are, for example, applicable to MPLS, and IP is not necessarily there. So, I mean, if we're talking only about IP, we're limiting our scope. And
Okay, so I'm going to make an individual comment. I should probably run up to the mic, but I'm lazy. Now I think I know why we have that line in there about putting that out of scope. Because, so on the one hand, yes, maybe. On the other hand, we've always been focused here on the types of measurements that you can do from IP endpoints. And it's very difficult to measure MPLS from an IP endpoint. You can measure it from an MPLS endpoint. But you can also measure MPLS. If you're an MPLS endpoint, you can put IP packets down the MPLS endpoint and you're measuring the same thing. Greg.
Hi, Greg Mirsky, ZT. Okay. I really like Tal comment because I was to comment about this sentence that was crossed. Yes, the network layer and lower layer is confusing because now we have many overlays that go above IP, and what about them? Because they do put packets, OEM packets on the wire, and they do have their own performance measurement on their layers or sub layers, if we want to. So I think that trying to generalize and look at performance measurement methodologies applicable to networking technologies being worked at IETF, that might be a worthy goal. And then try to scope out specific encapsulation, because specific encapsulation should be decided in appropriate working groups. So if we can combine, less emphasize IP performance measurements, because we need technologies for example, SFC, NVO3, beer, and they not necessarily run on IP data plane. They run on MPLS data plane, but they can benefit from their common technology, methodology. But at the same time, we want these groups to decide applicability of these methodologies and particular encapsulation. So if we can achieve this separation of authority domains, I think that will benefit everybody.
All right, actually, I am, just to make it very clear that I'm not speaking from the chair. Hi, Brian Trammell as an individual. I really like where you're going with that. I think the key is, so so there's commonality in methodology that's very interesting. It's not interesting because it saves code, although it also saves code. It's really interesting because you start to get comparability across these different layers, and that's not a thing that we've ever really had. And I think part of the reason that we haven't had that is that there's a little bit of a firewall between TSB and ops on this that shouldn't be there, right? I mean, the way that we don't have that firewall, or there are people who participate on both sides, like yourself. I am, chair hat on, I am not sure how to write charter text for that. It's hard, right? So there's I think we're opening up a bigger question that it's good that we have the time on the agenda to discuss is this a thing that other people in the room are interested in opening up and basically saying, okay, we have these methodologies, and things like altmark work very, very well at both sides. Things like IOAM work very, very well, both on IP paths and on non-IP paths. Do we want to bring essentially convergence in metrics methodologies, not protocols, not encapsulations, but in metrics methodologies, and have comparable metrics across that boundary. Discuss. I think we do. I'm not sure how to scope it. So the problem is that the naive scoping that I would write for that puts a whole bunch of stuff in scope that really shouldn't be in this room, right? I don't know. I think that by saying that we're going to measure, take these metrics that we have experience with, and take these methodologies that we have experience with at IP, and look at their applicability in non-IP networks, is very interesting. But I'm not sure how to scope that so we can get the right people in the room. So that'd be a question that I would ask. Yeah. Okay.
One way of at least separating ourselves from specifics of networking technologies and encapsulation of methodology on a wire would be to say protocol encapsulation on a wire is outside the scope. Again, it's not exact wording, it's not perfect wording, but along this line. So basically, we don't want to tell other working groups how that looks on the wire.
Well, I mean, we do want to continue maintaining our own active measurement protocols on top of IP, where we do have our wire formats, right? So I mean, we need to do it in such a way that OWAMP and TWAMP remain in scope, but anything else we come up with on the IP side remains in scope, but encapsulations in non-IP networks are out of scope.
Okay. Okay. In my other experience, so we do have bidirectional forwarding detection for continuity verification between systems, BFD nodes.
Yep.
That is applicable to IP.
Yep.
It was that technology was developed and defined in BFD working group, but applicability to MPLS is an MPLS working group, as long as it doesn't change the BFD base protocol, and so in all other groups. So applicability of BFD as a protocol to different layers, as long as it doesn't affect BFD base, is done on these working groups. And then for BFD is FYI. So it's cross-presented just to tell that we're doing.
That seems like it seems like a very good arrangement. I think actually what we should do is we should take to the list a new paragraph that essentially talks about the scoping, and then we refer to it forward from this paragraph, and then we make any changes that need to happen to this paragraph that contradict it, right? So I'd like to keep IP in the name of the working group because it's been IPPM forever.
Or it could be IP and
yes. IP plus performance metrics, and it's still IPPM because if we put a plus in a working group name, the tools people will hate us. Yeah, IPPPPPPPPPPPM.
Hi, Tal Mizrahi again. So I think the work we're doing today already goes beyond the scope of IP in some cases. So I think as an exercise, one thing we can try to do is remove IP from the charter and see what's the result, and consider whether that's valid or not. Another thing we can do is just add a paragraph that says, in some cases, the methodologies will go beyond IP, and that's still part of the scope of the working group. I think those are two options we can think about.
So Al Morton has another idea, not necessarily conflicting with these others, but I'll go back to the measurement thing later. Perhaps what we need most is our stated goal, which you just came to the microphone and I think we all agreed with, Brian. And that is that our goal is to encourage or foster better measurement commonality across the different layers. And the only way we're going to get there is to have recommendations that are broadly applicable. And we can always evaluate whether proposals are consistent with this goal and don't tread on, and so maybe there's another phrase there, without creating overlapping work, something like that. And that might be the way to phrase we're trying to do something good here. We're trying not to piss you off as well.
Right.
Yeah. So, and then back on the other page, consider IP performance methodologies. Measurement is what we do with all this stuff, but in the working group, we create methods and the surrounding
IP performance
trappings.
methodologies to me sounds like making IP go faster, which is not what we do. So what we need is
that's another way to look at it.
IP and P performance metrics and methodologies. So now the working group is IPPPMM.
Yeah. Okay. Leave it.
I think measurement. Yeah.
Thank you.
Carlos Pignataro, Cisco. I also like the spirit of what Tal is saying. I think there's great value in that. How that translates to the charter, however, I would really try not to innovate too much on the wording on this part and leave it as is. I would actually much rather have a targeted paragraph stating what you're talking on the other slide. Leave IP, leave everything as is. In addition, the working group will blah, blah, blah. I think that's a much safer way of attacking the problem. Thank you.
If I may make a comment again. All right, I'm gonna make a non-chair comment because I'm tired. So is it safe to say that we are not interested in methods or metrics that are not measurable at IP at all? Right, so it's like the way that we decide things are in scope or out of scope are, if it's not applicable at IP, then it's out of scope here. If it's applicable at IP and applicable at other layers, then it's in scope here, and we should make sure that we explore the applicability of those other layers.
Carlos Pignataro, Cisco. I think that's the same thing that I was saying. Look at it from the other way, right? And I think that's a perfect way of stating it, right? It's because within the charter, you're trying to get clarity both what's in and what's out.
Yep.
And if it is for IP, it's in, but it's also within charter to go and explore. And the other thing the other keyword that I think needs to be on the charter as a goal is collaboration with other working groups.
Yep.
And that means, hey, we need this encapsulation, SFC or whichever group, right? That doesn't get defined here.
I would say that that's not actually, so it's not a goal, but it's a major method of how we meet the first goal, right? It's like, we'd like to foster measurement commonality and
means to achieve,
comparability, yes, across different layers. We could do that by being the working group where all the measurement in the entire IETF happens, but that's not going to happen. So.
Thank you.
Thanks.
Hi, Dave Allen Erickson. Actually, your last comment pretty much echoed where I was going to go, because when you start talking non-IP, you make me a bit nervous.
Yeah.
And in
Right.
reality, what you're talking about is IETF technology.
Yes.
And if that was simply made clear, because just about everything that's not IP in the IETF is some form of IP helper, or a shim
Yes,
layer
right.
like beer or
Right.
MPLS.
So
or anything else.
so what we mean in the IETF when we say non-IP is things like MPLS, and what you mean in BBF when you say non-IP is the entire management layer that's down below that. And there's no reason.
Well, I mean, we could be discussing Zigbee.
Right, yeah.
There's a trillion
there's a bunch
technologies
of
out there
satellite
where we have
protocols. Yeah,
nowhere to go.
exactly. Right.
Nowhere
Yeah.
we should be going.
Yeah. So I think a good way. So that this makes me a lot more comfortable with this than when Tal first got up. I think by basically saying that the scope is it applicable on an IP network, then yes, then let's look in the other layers that it might be applicable at and foster cross-layer collaboration. We don't want to say cross-layer in the IETF, but there's wordsmithing to be done.
Yeah, but I think you want to make that IETF technology
Yes.
part clear.
Yes,
Because
absolutely.
Ethernet carries IP.
Right.
You're not doing Ethernet.
We're not doing Ethernet. Yeah. Right. Good. Thank you, Dave. I'd actually, chair hat on, I'd actually like to ask for any comments from people in the room who think that this is a terrible idea. Get up. Yell at us. All right. That's pretty good. Okay, cool. That sounds like an answer. Let's actually get through the really easy editorial stuff now. So I think we're going to have to do a little bit more wordsmithing here, and we're going to have to take this discussion to the list. I think we've got good input from the in-person discussion here. I think that we can get to something that we can iterate on relatively quickly. I think I understand where the scope is. Bill, are you happy with? You think we can bang this out? Okay. All right. Let's do some easy ones. We're rechartering the working group, so we can take out the line that says we might recharter the working group. There was a comment that we might want to remove the dependency on 6390 since PMDIR doesn't really seem to be much of a going concern anymore. But I think that the framework in 6390, we've actually figured out how to work with it. So I don't see any reason to actually pull this out. Like, it's as a base performance metrics template, it's actually pretty good. As a performance metrics template that defines how you measure things, we've kind of augmented it with the registry. So,
Morton. So 6390, I felt, was never intended to apply to the working groups that already had good templates.
Right.
And this got jammed in at IESG time. I think, we leave it, but we respect it.
Yeah.
So
Yep.
Enough. Yeah.
Yep. Paragraph 6, this is a tense change. We said that we were going to define a registry. Now we're defining a registry, so we can make this present. Paragraph 7, we've got two, so there's two, can you even see the different shades of green here? There's two things that we're adding here, and I wanted to talk about them separately. One is we talk about context. So anything that we can get, like just a metric in isolation doesn't give you anything really actionable, right? A metric in isolation with a couple of endpoints and some type P gives you a little bit more. A metric along with all of the metadata about how it was created, which tools, how was the measurement set up, references to other things is much more useful and comparable, right? So our goal, and I like the where we got sort of in the more points on charter on what our goal is we're really at a point now where we've got the metrics and we have some experience with them. Now we want to foster comparability. And one of the big ways to foster comparability is to make sure that when you're looking at measurements, you know as much about the environment in which the measurement was taken as you can. This text was written to be extremely general, and we thought it might be useful to add some examples here in order to make it clear what kinds of context information we think is interesting. So measurement implementation information, not just with which methodology we're using, but which revision of which tool was being used, because there are always bugs in active measurement methods. There are always bugs in passive measurement methods. You'd like to be able to know whether you've got invalid rows because you found a bug later and it's like, okay, well, I can't rely on that data anymore. Conditions on the networks on which measurements are taken. So, if you're in, this is especially important for passive, right? So if you're doing, or even active, right? If you're doing a study that's using a lot of ripe atlas nodes, knowing about the load condition on those ripe atlas nodes, it turns out gives you information about the fidelity of the measurements that you're running. And or information about the data plane topology of these networks. We have a whole bunch of work on spatial composition of metrics across paths and no way to measure what those paths are. So this is let's think about traceroute and let's think about in-band OEM, and let's think about other ways that we can get path information into our metrics. Huh? Lots of methods. The second one is something that actually came up after our discussion. Let's talk about the first one. So this is not, it says, for example, but not limited to, and this is really clarifying text. So we can probably do without it. but it says that right now we're pointed in the direction of looking at these sorts of information. Because we also don't want to say, hey, we're going to collect a lot of metadata, including the user identifiers or the people who are involved, because that would not work. So we want to be clear about the type of contextual information that we're interested in. Are there any comments on the dark green part of this text before we go on to the light green?
Frank Bruckner, it's more of a question than a comment. Given that you're considering multiple implementations and we have multiple methods and tools, would it make sense to also have some qualification of confidence of what you can get from a particular implementation or tool? I'm just thinking of situations like if you're using ICMP and ping, not every router vendor handles ICMP packets in the very same way. Which impacts what you're getting as an outcome of that particular measurement, especially thinking of the earlier conversation that we were having around using ICMP as part of the registry for metrics that other people will, well, use for decision making or qualification of a network. So is that something that we could go and add here? Is that in the same vein of what you were thinking of, or is it something different?
Yes and no. So yes, in that it's contextual information that gives you a better idea about comparability. No, in that we actually, so the contextual information is on a collection of measurements, and the error bar should be on each measurement, right? If I have a long series of pings over a period of time that are between 52 and 53.5 milliseconds, I have a pretty good idea that 52 is, I mean, it's within, I have high confidence in that, right? Because I have 1,000 of them and they're all about the same. If I have a lot of those and then I have a ping that's 2 seconds and there's only one of them, I'm not sure I believe that.
What's your level of confidence in ping in that case?
Right. The level of confidence in ping is not great. So there's a base level of confidence, but then there's also sort of statistical analysis that you can do. So confidence is, so I think what I'm getting
there's two
is,
levels of confidence
right,
that we're talking about here. I think
yeah,
it's the confidence in the measurement itself.
Yes.
And the confidence in the tool being used to get to the measurement.
Right.
So it's, I think, the methodology and the measurement.
So I think that methods for measuring the confidence for the types of measurements that we've done so far, methods for quantifying the confidence that we have in measurements still seems to me to be, on a single measurement, is an open area of research, right? Like being able to look at ping, it's hard, right? Having the ability to, I mean, there are other methods where you can do cryptographic things, for example, where you have more confidence because you can actually quantify the number of bits that need to be wrong for this measurement to be wrong. But in ping, it's really, really hard to quantify the things that can go wrong with ping. There's like a whole subfield of internet measurement research about unbreaking ping. So yes, this is absolutely in scope here. I'm not sure how to capture it because that one term captures two different things, right? And we need to make clear. So I have a note here that we should figure out how to get that in, but we need to make clear that we're not confusing the two kinds of confidence. Other comments on this list of examples? I mean, yeah, so with the note, please don't put every single example in here because if it's a list of examples, it's got like 5 examples in it, then it's good. If it's got a list of examples, it's 20 examples in it, then people are going to treat it as if it's complete. And if it's not in the list of 20 things, then it's not on Charter. I think we're good here. Are there other comments on this point? Moving on to the light green section. This is actually that's a terrible highlight. We're going to leave that unhighlighted. This is something that actually came out of the Applied Networking Research Workshop that was held in this very room on Saturday. Wow, it's been a long week. It may foster this work by defining information and data models for the storage and dissemination of measurement data. And what this is that we have a few measurement platforms and a lot of sort of research grade measurement studies, all of which define at least one of their own and often more than one of their own data formats for data storage and exchange. And if you're trying to do like actual comparability across different tool sets or different metric sets, you spend about 80% of your time writing parsers and about 10% of your time assigning confidence and the other 10% of your time doing work. It seems like there could be a better way than this. Personally, I had an offline conversation with some of the Ripe Atlas people, and they would be amenable to take their experience with data formats on their platform, which is relatively large. It does traceroute and ping and some DNS response time stuff, right? It's not a large distributed OWAMP infrastructure. It seems like we do know some people who run large distributed OWAMP infrastructures, and we could possibly talk to them about their data models, but they seem to be slightly heavier weight than what Ripe has done. And it seems like this would be a way to have a conversation about how can we learn from the experience of some of these measurement platforms in order to define ways. It's like, okay, well, if you're going to publish a thing, like, so you say to this broadband mapping thing, if you publish it and if there's a standard that comes out of here that says you've referenced this and this is how we represent this, and you know that when you're parsing it that you can use the same parser and it means the same thing, that seems like it might be very useful. So comments on this part?
Carlos Pignataro, Cisco. I support what you're saying as a concept. I think it's great. I don't think the text as it is reflects what you said.
Okay.
Because I think it's fairly generic. And, in particular, the one specific concern that I have is to mark a, finer demarcation between work in Lime. Because, part of the work there is about data models on some OAM things, which may include some, way in which we export measurement data. So, if we can disambiguate with Lime, that would be great. And I think the way to do that is to add more precision to the text. It may end up being longer.
Yep.
But that's the reason.
Seems like that might be another paragraph because paragraph 7 is already getting pretty long. We can put a paragraph break here.
I think it doesn't follow necessarily, right?
Yeah,
So
right. Yep. Yeah. So we're actually kind of talking about a separate thing, right?
Yes.
I think this ended up in paragraph 7 because I was editing paragraph 7 while the ANRW thing came up. So, could you help and suggest text here?
More than happy to.
Okay. Excellent. Thank you.
Frank Brockmers, my point was very much along the same lines, kind of understanding what the relationship to the work in Lime would be. Are we going to go and define Yang models for that, or are we going to go and do something else? And also the other thing is like, well, I'm not a native speaker, very obviously, and I have really difficulty decoding it may foster this work, what that actually means. This is as fluffy as you can go, right? So saying what we are going to go do and what we're not going to go do is probably helping the process.
Great. Yep. Excellent. So Carlos will send text. So one thing that I think is the problem here is that in the internet measurement research community, data model means something very different than it does in the operations community. So in that, it's basically the information model is the set of classes and sort of what attributes they have, and the data model is how you bang that into a JSON object, right? So it's a much less or into a CBOR object or into CSV or how you represent it down. It's a much less precise term of art in that area than it is in terminology. That was an unfortunate and unintentional terminology collision. So I don't want to open mic the charter at this point because it's like, oh, rechartering. Let's put in some ponies. Spencer's chuckle means that he would also like us not to do that. Spencer, could I ask you to come up and could I take the temperature of the AD on this one, or can you just can you give a Roman gladiator if you don't want to have to walk all the way up? Okay, cool. Yeah. Let the record show. Thumbs up from Spencer. All right. So with that, let's talk about stuff related to what okay. So the outcome, the action item is Bill and I are going to take text from Carlos and the comments that we had here. We're going to propose, probably we're going to stop talking about just diffs at that point. We're going to propose a full charter to the list, and then we'll iterate on that on the list, and then we'll hand that up to Spencer, and he pushes all the magic data tracker buttons, and then there's a discussion in the IAB, and then there's a discussion in the IESG, and then we get a shiny new charter. So with that, Frank, thank you all very much.
Okay, so a brief update on in situ OEM and the data draft. Just go to the next slide. I have a single slide on that update. Can I put the mic a little further so that I can stay in the girly area here, and or just take it out. Okay. Well, it's still.
Oh my gosh. It's redrawing things. It's letting going all across the internet. Can't do it. Can't do it.
Sing a song. I can't sing.
Oh my gosh.
Yeah, just don't go to presentation mode. Maybe that's the solution.
I have very low confidence in this measurement method.
Yeah. So right. So I think even harder would be to give me a number on how well it does. It's 27 or 48 or 42. So we received a ton of good comments post the Chicago meeting, and one particular area that we put a load of additional text in actually in our new section is that in situ OEM is really bound to a particular deployment domain, and that we want to go and from an implementation perspective make sure that we're doing everything that we can in order to keep the IOAM data fields to that particular domain so that they're not leaking. And in addition to that, also put some impetus on the operator to make sure that these data records don't leak. So that was a major concern. So we edit that section with kind of scope-specific information for in situ OEM, and the deployment domain, I think, is explicitly spelled out, and we've done a load of wordsmithing even over the list to go and get there. The other thing that we specified as part of the scope section is in situ OEM control points, which is encapsulating, decapsulating, and transit nodes. Encapsulating puts on the header, decapsulating removes the header, and transit nodes either update or add to the header. Then we also had a clarification that in situ OEM doesn't necessarily apply to all the traffic, but can apply to subsets of the traffic. And again, you can use some classifier to decide on what that subset of the traffic would be. That goes well hand in hand with other drafts, like we've seen the UDP pinger draft from Petr Lapukov and team, so that, well, the UDP pinger can be used within situ OEM, which is why Petr is a co-author of the draft. We clearly stated that encapsulations for in situ OEM will be done in a variety of different working groups, i.e. it's out of scope for what we're doing here, but it would need to go into the various transports. So exactly what the new charter should go and try to achieve. So the earlier discussion that well, Tal and Greg drove, we'll have multiple layers. Eventually, these layers can all use in situ OEM data formats. Hopefully, they all use the same formats. So that's what we want to go and achieve here. So that also talks about the layering aspects. It's absolutely possible that you have a tunneling protocol like Genève using in situ OEM, and underneath you have a transport protocol like IPv6 using another for itself flavor or instance, I have to say, of in situ OEM. Well, obviously, we also want to go and specify things that they can combine well with other OEM mechanisms. So I already mentioned the UDP pinger from Petr. That comes along quite nicely. In addition to that, there is one change that we've also done for TWAMP and OWAMP, as well as for NTP, that we have a field to make the overall insertion of information that we're adding checksum neutral. So that's an option so that you don't have to recompute the checksum if your protocol uses UDP, but you're staying where you are, and that's exactly the same mechanism, and that's taken reference to RFC 7820 and 7821. And so that's another addition. And another change, given that we've seen quite a few silicon vendors even putting the thing into silicon as we speak. I don't want to go and kind of iterate through the names again, but we've seen at least 3 public announcements. Plus, we have the open source implementation. So things are moving, and things are moving quickly. So let's make this a standards track document that again was a comment on the list, rather than the originally proposed experimental version. And in addition to that, a big thank you to Joe Clark and Al Morton, who've done a thorough read-through, and we were able to iron out a load of editorial nits. One thing, if you read through the list, we've added a scope section. We've done one update to the data fields and a lot of editorial nits. So you see that the document is stabilizing by now quite nicely. So I think we're achieving what we wanted to achieve, which is also probably why the working group adoption call went quite well. And that's what I had.
Thank you very much. So actually, as a procedural note, I think we're going to, just so everything is nice and clean, continue doing any further edits on this as draft Brockners until the recharter goes through. And then as soon as that's happened, the adoption call that we already did will take effect. Right. So I don't think we need to do another adoption call. We already have a pretty good run of rough consensus on that point.
No, different part.
Okay. So yeah, please ask a question. So, oh yeah, well, let me finish. We have a pretty good indication of rough consensus that this should be an IPPM. Okay. Now we have a charter that should fit. Well, I mean, we almost have a charter. We needed to go through the rechartering. Once that's happened, we can bring those on as draft IETF, IPPM, IOM. All right.
Sounds good. Yeah.
Thank you. Okay. Yeah. Yes. Shahram Devari, Broadcom. So we have a bunch of customers that only want the end-to-end in-situ OEM. So for that reason, I noticed in your draft you only have a sequence number for the end-to-end, but we also need timestamp, for example, to measure the, in replacement of TWAMP OWAMP.
You can have timestamps, right? Absolutely. There is data fields for timestamps.
Not for end-to-end. Only for the hop by hop.
So the question is, so there is the restriction for end-to-end where only the inserting and the removing will ever touch that particular data field. But
that's what I want. Yes.
You can have also, if you're using the kind of hop by hop one, it's still that
I'm not using hop
individual. No, but individual nodes in between can miss out, right? So you can still use the hop by hop.
You're saying use the hop by hop and
all the intermediate nodes, but starting at the endpoint. So I think that specific case.
How do you tell the other ones don't touch it?
Okay, but I think that specific case is covered with what we have. If we want to make it more clear, we can absolutely do that.
Shweta Cisco. So we have a subtype in E2E type.
Maybe come a little closer to the mic.
There is a subtype in the E2E option type which can be used. Today it's defined. There's only sequence number defined. We can define a number of other data type. I think somebody in 6-low PAN has done timestamp. I can send you the reference to that draft because they also wanted end-to-end measurement.
The second thing is that the timestamp formats you have right now is only PTP. Do you want to add NTP to it also or not?
Well, take that to the list. I think that as well as the first comment, right? So it would be good if you can get those onto the list.
And the third one is not exactly clear how to identify there is in-situ OEM in the packet or not. How do we know it is there or not? IPv6, we have options, but how about the other one?
Well, I think that's a transport-related question.
Yeah, I know.
Is very difficult to be resolved here.
Yes, okay.
And I think from a procedural perspective, what I would expect happening is once this is a working group document so that we can officially refer to that in other working groups,
Mhm.
we will see there's been this kind of scratchpad document that we call the transport draft that has
Yeah, I saw
proposed
that.
encapsulation
Yes.
for
There's like 6,
X,
7
Y,
different
Z,
ones.
right?
Yes.
That we're starting to have individual drafts on these individual encapsulations, and then we can, per individual encapsulation, address that specific question.
Right.
Thank you.
One comment on this side with my I'm a transport guy, TSV guy hat on. Don't call it transport draft. Transport means something different in OEM. Yeah.
Yes, yeah.
You will get lots of confusion.
Sorry for the loose
Sorry.
language.
Yeah, right. You will get.
I'm happy to stand corrected
yes.
here. Yeah.
Well, no, I'm just
Give me
saying.
a better name.
Encapsulation.
Encapsulation draft.
You're going to get a lot of confused comments that aren't going to be helpful.
Sorry for that.
All right. So next up, and we're running a little behind on schedule, I think. No, we have 10 minutes for the next two presentations. So we're running a little behind. So speeding up would be good. We have 10 minutes for the next two presentations, right? So I mean, yeah, you can. I mean, like we're probably going to end up going over on this anyway, but please try to be brief.
Okay, so we all know that IOM is a terrific technology, but when we actually implement that, we need to consider what's the impact to the actually data plane performance. Also, we need to consider in the future how we will make the solution really scale. So in this proposal, we have addressed several issues, all based on some real use cases. So I go through them fast. The first one is about how to scale to support more data types. So currently, there are only 16 bits are used for data types can support at most 16 different types. But currently, 40 have been defined. Only 2 bits are left. So we propose to use actually reserve last bit as an indicator to expand the data type. So, for example, if this bit is set to 1, we can have which means another bit map will follow the header. So this way we can extend 31 up to 31 more new data types. So again, we can use the last bit to indicate the availability of the next bit map. So we can do this to support arbitrary number of new data types. So we can imagine there are many different use cases to support new data types. So I will skip this, but you can see there are many different possibilities. So the second one is to deal with some potential limitation on the path length and MTU, because also we may have just limited budget to hold the IOM data. If the path is very long, then the overhead may be too large. So to resolve this issue, we propose to use one status bit to indicate the segment IOM. So the concept segment IOM is we give a fixed size of the segment, and we only hold the IOM data up to the segment limit. And at the segment edge, we'll remove the header and we just send the data to some management entity. And we start working. And we partition this length field into 2 parts. The first part is 4 bits used to indicate the segment size. So which means that each segment can be up to 16 hops. And the second part is used to indicate the remaining hops in the segment. So there are also some use cases. For example, if we have fixed budget to hold the IOM data, we can calculate how many hops we can support in each segment. Then we can configure the segment accordingly. Okay, I will skip some other use cases. You can read this online. And the last one is there are some possibilities for various reasons. Some nodes just cannot provide the IOM data or cannot provide part of the data. So how to handle that? We propose to use a valid data node bitmap to indicate which node is valid to provide the IOM data. So if some node can pass the header, but they prefer to not add its own data to the node, then it can just reset its corresponding bit in the bitmap. So which means in the following data list, there's no valid data for this node. Similarly, for each node, we have another valid data bitmap to indicate which data in the list is actually valid or not. So if the bit is set to 0, which means that data is simply invalid. And use cases as sometimes maybe the traffic is very heavy and the node just cannot keep up with. If it want to add data to the node, maybe it's in danger of drops the packet. So in this case, it's rather to not add new data to the node. I can simply set the invalid bit. So there are some other minor issues, or try to address the performance issue, how to make the implementation more efficient. But so I won't talk about it. So any question?
Thank you very much. Next is, so he's basically just going to do this. He'll put himself in queue and then I'll beam him in. Ignacio, can you put yourself in queue? Waka, 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 waka. And we'll beam him in. Hello, Ignacio.
Hello, hi everybody. It's too early here. I will start with advanced unidirectional route assessment. It's a draft proposal with joint work with Al Morton and Joaquin Fabiani, and I am Ignacio Alvarez Amelan. Well, let's start with the objectives. Here we will propose 3 objectives. A new metric, which updates the section 5 of RFC 2330, a framework for active and irreductive passing methods, and also on round-trip delay measurements statistics. Next slide, please. Well, this is just a toy network to make our examples. We have a source and destination nodes and some routers in the middle. Next slide, please. Here we want to identify a particular flow from a source to a destination. And in particular, the flow is identified for IP source address, IP destination address, the port source number, and the port source destination, and also the protocol. Next slide, please. We can see that normally there are different flows from source to destination because the different routing policies or balancing, something like that. And we want to measure the different flows. The idea is to measure round-trip delay from source to every intermediate hop. And we want to call this TI. I is the intermediate hop. And the host identification is the IP ingress interface for active measurements, or alternative identifier in the case of in situ or OAM. We also call discoverer host according to RFC 1122. In this case, the host G do not decrement TTL, therefore is not discoverable. Next slide, please. we identify two different things: root member, which is for a particular flow, in this case the green one, which is the set of round trip times, TA, TB, TE, TK, TM, and the destination. And also route ensemble, which is the every possible flows in order in the successive hops distance from the destination. Next slide, please. And finally, this is the formal description where we can see that every hop has a hop number and also the number of flow or the number of alternative route. Okay. Next slide, please. Well, we are interested to define two groups of route assessment methodologies. Active methodologies, mainly based on trace route, and here we propose to use Paris trace route, which is a tool developed in 2006, and there are new versions. Because this is a flow-wise tool, which means that can identify, in 99% of cases, every hop for every flow that joins a source and destination. We have different tools like Scamper. Scamper is includes many other features, but also implements this idea proposed for Paris trace route. We also want to highlight hybrid methodologies like in situ or OAM, where nodes can add timestamp and route information in every step, in every hop. Next slide, please. Well, the type P route ensemble method variant should verify different things for different kind of protocols. This is some kind of abstraction of the ideas around Paris trace route. For instance, if the proofs are TCP, we want to maintain constant the source and destination address, the port and source destination, also the field DSCP, in order to be observed as the same flow. For UDP, it's a little more complicated because we want to ensure the backward path. I mean, we are measuring round trip time. We can know just the IP of the hop, the ingress IP number, but the backward packet, which is ACMP, can follow different paths. The idea is to maintain the idea to follow exactly the same path for this hop, this particular hop. And for that, we need to observe the UDP checksum. And well, this is a little more tricky because we need to manipulate some data into the packet in order to assure that. And for ICMP proofs, we use normally the data field to compensate TTL and IP checksum. Please, next slide. Well, what are the goals to measure this round trip time? Here we highlight 4, but perhaps there are more. In particular, we want to identify intercontinental submarine links, satellite communications, congestion, interdomain paths. I added some articles related with these 4 problems. In particular, congestion is a little tricky, the definition, but the paper that I highlighted for this item is related to compare the minimum RTT versus the actual RTT. And when you see some some variation, you can see, okay, you are facing some kind of congestion. And we can add more eventually, but this is the four first type that problem that we want to find using this tool. Next slide, please. Well, this is just to illustrate one of the picture that we can get when we are doing some statistics. Here we perform some round trip delay during several, for instance, 1 hour, and 1 packet per second from the one particular hop. This is 4 cases, different cases, and we can see here that the queue are really heavy, really long. This is the reason, because we want to find some kind of indicator, some kind of measurement that can get some idea what is happening. Please, next slide. Then our idea of statistics is based mainly on trace route. I forgot to put the David's method, but in this case, if we use trace route, we should use something like Paris trace route, which assures the route. And the idea is to use quantiles for represent each hop. The quantiles are typified by the minimum and maximum time, and the quantiles, the first, the second, and the third, which is the 25%, the 50%, and 75%. And we propose to use P2 algorithms that can be able to compute quantiles online, which means that you can do this inside the router or inside a computer, what you want, because you just to put every measurement, and he can update the quantiles. And even if you want another kind of quantiles like percentiles, you can do that for the quantity that you are really interested in. Next slide, please. Well, this is the algorithms that show an example what we are having in our mind. We are sampling during some time window. We use some time between 2 measurements. We say if you want to be exhaustive, which means explore every possible path, every possible route for every flow, of just a single flow. And we got destination, and the output is the quantities. And this is very simple, just to, you got a loop during the time window, WD, and you just perform your advanced trace route, for instance, Paris trace route, Scamper, or what you want, and you collect every measurement and you compute the quantile for every measurement. This is all. Next slide, please. Well, we got some feedback of IPP mailing list, and we have to incorporate some standard term for RFC 2119. We have to define discovered host in terms of the RFC 1122. Perhaps an idea more complete than that. And we need to make a clear parallel links about what can be detected. The parallel links for instance, for hops, which means perhaps at the same distance, 3 hops away, you can get 3 different IPs. But the problem with that is some routes can have more links than another. Okay, we have to define this clearly. And what parallel links cannot, for instance, parallel links. We can distinguish also about the coverage methods, the active and the hybrid, or what another method that we want to use. We want to explicit more how the methods can be combined, and also to highlight the security considerations. For instance, changing fields to keep checksum constants normally have not to introduce any security problem, but we have to write down that. And also in situ OAM. There are several areas to discuss between root metric and in situ OAM. For instance, what happened with the checksum is have been removed, and okay, how to deal with that. And also more feedback will come. Next slide, please. Well, with this slide, I finish. If you have some questions, we'll be happy. Thank you.
Hi, Greg Mirsky, ZTE. First question is, have you considered alternate marking method as one of the hybrid methods to instrument the measurements?
Well, perhaps we can introduce that, but my problem with that is that we are interested to measure every hop of a flow, and normally this method needs to be assisted with something in the node, because with your methodology you need to have something in the hop in order to establish this time. This proposal is related with round trip time, and using your methodology perhaps it's more oriented to one-way measurements. Yes, but perhaps we have to think about how to introduce some kind of one-way measurements. Thank you.
Well, if yes. Yeah.
Mic on. This seems like a really good bilateral conversation to have.
Okay.
So the two of you should talk to each other and report back on it in
okay. And
Singapore. Because so I don't actually see how it works, but I'd actually like the two of you to talk about it and then propose something.
Okay. And the question is, so you pointed out to the challenge of ensuring of co-routeness of the rounding trip path.
Sorry,
so, you pointed out to the challenge of ensuring that your round trip path is co-routed.
What's the last word?
Co-routed. So basically that you're crossing the same links.
Co-routed.
Yes, you're crossing the same interfaces, links, and nodes.
Okay.
The similar problem been identified, for example, in a lag, because there are different hashing mechanisms. So what they came up is that realized and protocol that pins flows to the particular constituent link. So do you see that there is a need to do that to ensure co-routedness, or you think that because there are different policies of doing hashing in ACMP, and you may need to play different game to do that in your measurement?
Well, ACMP it's for normally for the returning path, okay, you can use ACMP for the forwarding one, but normally the problem arises in the returning path. And yes, I know there are different hashes methodologies, but normally the Paris trade route normally works for the returning path too, because they try to maintain several fields constant, and sure, sometimes it's not possible to maintain the returning path constant, and you can get some problem. Yes, sure, it's not perfect, but the idea is to use the best way to do that, and okay, it depends on routers, not on us.
And that leads to my next question. This might be it's better to look at round trip delay as two one-way delays. Do measurements as one-way measurements.
Well, it depends, because as already said, to do one-way measurements, you need to get some support in the intermediate hops, which is normally it doesn't exist. I perform a lot of trace routes around the internet, and even if you need to use a IP timestamp option, normally is not supported for intermediate routes. It's really hard to get information what you are not controlling the intermediate routes. The idea of this graph is that you can use this methodology at large in internet, not inside a single domain where you are controlling that. And also for one-way measurements, you need to synchronize clock, which is really hard to do if you don't have some special hardware assisting you. And I think it's very interesting to get one-way time, one-way measurements, but you need a lot of support for the intermediate hops.
Thank you.
All right, thank you very much. Greg, don't go away. So that concludes sort of the rechartering and work covered under the rechartering. The intention for the previous one is to ask for adoption at some point after the charter is in. I guess we can do that either on the list before Singapore or in Singapore, I presume. Is that, or do you want to do something entirely different with it? Okay. Okay, so we'll do that between now and Singapore. If it's ready, if you guys want to rev one or two more before then, just let's take that to the list. All right. Now we're going to talk about TWAMP, TWAMP Lite, TWAMP Test, and how we're going to fix the ambiguity about these that we've had. This is actually kind of an externally clocked thing. This is why I brought this work, even though there hadn't been a whole lot of discussion about this on the list. This actually came in from BBF requesting a way to get a port assigned for TWAMP test traffic, where the control, I understand in the BBF application, the control is actually happening over TR69 or something comparable, right? So it's like there's a BBF control plane and then TWAMP test on the data plane. So you need a port for this so you can actually do control with it. And this seemed like a good opportunity to have the what is TWAMP, what is TWAMP test, what is TWAMP control, are these separate protocols, is TWAMP Lite a thing or not, conversation, and figure out how the best way is to get a UDP port assigned to this. So Greg, I think you have two presentations on this, and then Al has one, and then we're going to have a bit of discussion.
I would probably be better if we have two presentations on a port
Yeah. Okay.
together.
Okay.
And then,
I would say so you, then Al, then you.
yes.
All right. Okay. Let's do it that way.
Okay, great. Thank you. Okay, so this is just a very quick update. What this draft is about. As Brian pointed out, there is interest on have allocated port that can be used as a reflector port in TWAM test, or at least in a version of TWAM test that is not controlled by, not instantiated by TWAM control protocol. We had a discussion in Chicago, and there was a great discovery made in Chicago that when TWAM, OWAM and TWAM protocols went through IANA processing, both received not only TCP ports for their control protocols, but were allocated the same number from the UDP port range, and they were accordingly assigned to OWAM control and TWAM control. So we changed request for allocation to port reallocation to take these ports that have been allocated for control protocols and allocate them to test protocols, respectively OWAM test protocol and TWAM test protocol. So in our draft, we only talk about TWAM control. So this is a capture what we're proposing. The port 862 TCP is used for TWAM control protocol, and it was allocated a UDP 862 and assigned to TWAM protocol. So their recommendation is to reassign to TWAM test protocol as TWAM receiver reflector port, and use it as default port in TWAM test. So effectively, this is all what this proposal does.
All right, Al, might you have a similar proposal?
Yeah, it's actually my proposal. Okay, that's not my slides though. That isn't either. That looks good. Let's go with that. Okay, so controlling TWAMP test-based measurements using alternative means is an idea, and it's a good idea, I think. TWAMP Lite also suggested this idea, but we'll talk about that more in a minute. Allocating a port for TWAMP test would help, obviously, and that's this precise request from BBF. So I proposed this reallocation solution in Chicago in discussion at least with 3 or 4 different folks. And then we also had this question about what is TWAMP? That came up in the meeting. So I decided, well, let's write a draft, or I'll write a draft, that solves all the questions that emerged in Chicago and answers the questions, I think, in the best way. So we don't have an ability to negotiate the use of TWAMP Lite without the control protocol. And that was a key consideration in why TWAMP Lite got moved to an appendix. It was actually Lars Eggert's AD comments that caused that to happen. And further, we actually had to reinforce that because TWAMP Lite, which only mentions the test protocol and has proprietary means for other communication, it basically has no way to communicate the required keys in order to operate in a secure mode. And so it had to be sort of relegated to this appendix. And as we know, it's mandatory for all the protocols in IETF to have sort of mandatory to implement security features. So that's kind of the background, and I've got more detail in the draft, and especially links to the messages that, that discusses and AD comments and so forth that resulted in this lineage. But that's why it's a very explicit requirement for both the control protocol and the test protocol in OAMP and TWAMP to be together. So let's talk about that. But first of all, we're going to recall RFC 7799. We had to go back beginning in Hawaii and define what active and passive and the new form of measurements, which we're very glad we define now, the hybrid, type 1, type 2, and spatial. It was very good and very important to have an RFC that defined things clearly for our work. And why do we need to do that? Because we're a standards group. We have to have definitions of terms that we can refer to unambiguously. And when we don't have those, we can use the dictionary. The dictionary is usually pretty good too. We can't define every word in the English dictionary here, so let's not waste our time with that. So in order to have unambiguous terms in OAMP and TWAMP, we have to consider the text that's there. So OAMP actually, that's an important word here, it actually consists of two interrelated protocols, OAMP control and OAMP test. And when you look at the dictionary definition of consists, it's very explicit. It's made up of, composed of, and there's no ambiguity here. It's two protocols. So the OAMP control and OAMP test are defined in sections 3 and 4. And we've got a very similar sentence in TWAMP. It consists of two interrelated protocols again. And it refers back to the OAMP definition. And remember, neither of these documents, standards track OAMP and standards track TWAMP, they would not have gone through the IESG successfully if they didn't have both the control and the test protocol as mandatory plans. So what is TWAMP Lite? It's basically an idea. It's not this light bulb necessarily, but that's what it could be. The point is that TWAMP Lite is really just an idea. It's an informative appendix. It gave the possibility for other forms of control, but it's just some information. There's not enough information there, not enough detail for anyone to claim compatibility with TWAMP Lite. There's too many details left wide open. And so a rigorously specified set of protocols that reuse TWAMP test truly need a new name. BBF has their own spec number, so there's no ambiguity there. I think that will work fine. But if we work on things here, we need a different name other than TWAMP Lite as well. So in my proposal, we do what I said in Chicago, and we do it for both OAMP and TWAMP. We basically take, this is the UDP assignment, and it used to be control, now it's test. And I've been thinking about this for a long time, in fact. When I wrote the IANA section for TWAMP, I really just followed what they had done in OAMP. And it wasn't the right thing to do because the control protocol is TCP only, and the test protocol is UDP only. So if we were going to assign a port, it should have been for TWAMP test and OAMP test. So I'm fixing my own mistake. How about letting me do that? So here's the proposal. We clarify the names of our protocols for the industry. Standards track OAMP is a 2-protocol suite. Standards track TWAMP is a 2-protocol suite. We reallocate the well-known ports. That's the simplest solution here. Shouldn't get any worry about that. And also, let's take a why worry approach to what we do with what we let the implementations do with these ports. It would be pretty easy to try to specify something, but all the standards track TWAMP implementations are out there doing what they wanted to do without this help. It's the new protocols that take the benefit. So let's let those guys specify the specifications to keep themselves from shooting themselves in the foot by having this one well-known port and maybe multiple tests trying to contact that well-known port. That's a potential problem. So that's it. That's my proposal.
Do we want to discuss those two, or do we want to have?
Like
okay, yeah.
Like Sharam has a.
Sharam Devai Broadcom. I think what you're saying is that the light version does not have the control protocol. That's what it is.
That's right.
And you're saying that won't be the TWAMP?
It's definitely not TWAM.
So it's like, oh, MPLS. Also, they used to say you must have LDP or RSVP, and then eventually they say, oh, you can configure it.
You can what?
You can configure it, like
Oh,
SDN
yeah.
configuration.
Right. So things change, but we should if the implementation changes.
They call it MPLS TP.
Yeah, that's
No.
right. That's right.
Um,
So they changed the name. That's what I'm suggesting we need to do here.
Well, I can point that basically we do have Yang model for static MPLS, and it still would not be MPLS TP because MPLS TP is a little bit different. Yes, so it's, yeah, you basically have SDN environment and you don't have a dynamic distributed protocol, so it's a little bit different paradigm. So if we can agree that TWAMP uses distributed control plane protocol and uses TWAMP test protocol. And then we can discuss whether we work on something which is using SDN control environment, and then we talk about test plane separately.
So I'm not sure I understood what you said, Greg, with respect to the standardized terminology. When you said a distributed control plane protocol, what are you referring to?
That's, in my view, what TWAMP control is. So the TWAMP control is distributed control plane similar to LDP or RSVP, which does label signaling.
Okay.
To instantiate MPLS LSP. But at the same time, now we're developing data models that allow that to do without LDP RSVP from the SDN controller.
So I think you're agreeing with my definitions then.
Yeah, I'm perfectly fine that basically we can say that TWAMP consists of distributed control plane, which instantiates test instances. But at the same time, we can start a discussion on SDN environment, how it works there.
And something, and let's start that discussion with a new name.
Yeah.
A new categorization of this work.
That's perfectly fine.
I think that's the distinction I'm really looking for.
Simple two-way active measurement protocol, STAMP.
Yeah.
Are we done?
Yeah. STAMP is nice.
And if we're done if we adopt my draft.
So can you briefly summarize the differences between your two drafts to me?
I think, okay, in my understanding of Al's draft is the difference is that it addresses OWAMP,
right,
which is good proactive measure. I agree with it. And then it clarifies the terminology, which is fine too. So I think that will be easy to merge the two drafts, and because I don't see anything that, questionable in Al's work. And we have some security consideration section I think that might be useful too.
So can we merge the two drafts, appoint the two of you editors on a working group rev of this draft, and just call for adoption now?
I'll be glad to take the first steps to do that
Okay.
merger. I think
Well,
your section 3 and the security considerations.
Don't jump the gun yet.
I'll draw those in. Is that
Don't jump
okay?
the gun yet. We actually have to call for adoption.
Oh yeah.
We're gonna take a hum.
No, well, I wanted to be sure Greg and I knew what we were talking about. So yeah.
Okay, cool. So you guys are clear on what the thing is if the hum goes through, right?
Yeah. So
right.
just say it. Section 3 and security come into.
Yep. So the hum is on to adopt these two drafts as the basis, mainly using the approach in this draft, merged with the two of you as editors,
right?
On a working group draft to do definition of stamp or whatever. We don't have to hum about the name.
No, let's leave the name out of this. Yeah.
And allocation of ports for it. All in favor of that adoption, please hum now.
Mm-hmm.
All opposed to that adoption, please hum now. That seems pretty clear to me. Let the record show crickets. Okay, that's done. We'll take that to the list. Please begin work. And now Greg is going to present the stamp Yang data model.
Yeah. Now, when we have a nice, catchy name, I don't have to write this. I can call it stamp Yang data model. Great. Okay, so let's keep in mind we're talking about stamp. Again, so this is what we talk about and what I think that we kind of converging and agreeing. We have configuration client as the environment that talks to session sender and session reflector of the same T1 of the same stamp test session. To correct that. Okay, so what were the changes? We have two co-authors joined us, and we modified some of, extended some of their metrics calculation, packet loss statistic, percentile. Percentiles, 3 percentiles that can be programmed. By default, they're 95, 99, and 99.9. They defined as a floaties with the 2 decimals. So basically, it could be not 99.9, but it could be 99.98, for example. But the same percentile applicable to all measurements, to one-way, near and far delay in the round trip, and to one-way, near and far and round trip delay variation. We had some discussion whether it's flexible enough, and that we appreciate the consideration and the feedback, whether the same percentiles to be reported for all these metrics, or there is some use case where you want to have a different percentiles reported for different performance metrics. And DSCP handling mode. So this is these are some examples of the changes being applied. I just don't want to read them out loud. You can look at the materials that are being uploaded, or just run diff between version 7 and 9. You can skip version 8. So periodic testing mode for session sender, as we, I think, discussed in back in Chicago, we differentiate 2 test modes, continuous and periodic. In continuous, the test packets being generated continuously, and then operator can define the period of calculating metrics. In periodic testing mode, each test session has certain time it runs, and then it seeds, and after certain timeout period, all their packets, all information being collected, and the metrics calculated. But in periodic mode, this can go indefinitely. So basically, you can repeat the same test in its duration indefinitely. In our view, in our understanding, that it might produce a little bit different metrics, because, for example, in continuous mode, we stop at a certain time, and we don't wait for the packets that might be severely delayed, or it's like out of order delivery. In periodic testing modes, these packets more likely to be accounted for, because you have a timeout period for your test session associated. So that's the difference. So the packet loss statistics, we added loss ratio and burst and maximum and burst minimum metrics. Percentile, I already mentioned that we have 3 levels that can be configured, and that these 3 levels will be reported if they're configured. If they're non-zero, they will be reported for one-way, near, far, and delay and delay variation. So DSCP handling mode being defined, because there are some implementations that just merely take a DCP value of received test packet and put it in the reflected packet. or there are some implementations that allow you to configure explicit value for the reflector to use for the test session. Next steps now, we'll work on updating the document with a new terminology and refer to the stamp as a stamp data model. And we are looking to start work on supporting RFC 7750, which is DHCP monitoring. That's a functionality that reflector copies received DHCP value and reports it back in a payload. In our discussion, that's been kind of very interesting, especially for mobile backhaul, because there's in the multi-service environment, it's many cases when DHCP mapping was confused, and that's caused severe problems, and packets dropped on the wrong service because it's being mapped to the lower DHCP. And after we do that, or somewhere in between, after we at least change to new terminology, stamp, we would like a working group to consider adoption.
Any comments on this draft?
Hi, Sharon Devari, Broadcom. Yeah, I mean, I'm not related to your draft in general. We have a problem in measuring the average. You know, so I wanted to see if has anybody worked or has anybody proposed doing a running average or a weighted average instead of normal average. Because to do the average, you have to, you know, have all the numbers and then add them up and then divide by the number of packets you have received to get the average, which is difficult to do, or you need a lot of memory for that.
So actually,
Yeah,
on a matter of average, I can say, for example, for alternate marking method, it's good measuring average. Actually, because it does very easily.
So has anybody proposed any metrics like a what I call a running average? It's like weighted average. It's like W-ret in you know, queuing when you do the queue.
It seems like a comment
yeah.
on the registry draft. Here comes Al.
There's a kind of a running average in the RTP jitter evaluation. That's I mean, if you looked at that, Sharon?
I haven't, no.
All right, so go to
the reason I tell you it's difficult is because if you have too many flows, let's say I have, I don't know, 10K flows, I have to have, first of all, a big in the chip. I should have a big memory for to count those number of, you know, you need a counter for that, and you also need the accumulator for all the add them up, all of them together, which is a big number. So instead of all of that, I can just have, I don't know, like 16-bit or 32-bit running average. That's much cheaper.
No.
All right, so
we're
running out of time.
Yeah, we're running out of time, and this is
offline.
Do take this offline. This is an interesting conversation.
I think that's an interesting conversation. I see Giuseppe, he'll have as a leading offer on alternate marking method what to say, but I don't think that it has very scale threatening problem. I think that there might be something done to do good metric, but still maintain some reasonable resources.
Okay. Cool. Thank you very much. All right. Welcome to the lightning talk round. Go fast. This phone will beep, and then we will all clap. Giuseppe, go.
Okay. This is a new document that belongs to the marking method draft, and adds a new concept, a new way of thinking about alternate marking method. Next.
Okay, there should be a.
Okay. So the alternate marking method seems to be applicable just to point-to-point flows, because you need one marking point, and you have once you individuate your flows, you can have your counting points. But now the idea is to generalize this methodology to measure any kind of unicast flows. So if you think that there are also some application when you have a lot of flows and a lot of monitoring points, the order of magnitude of the marking method counters could increase, is n multiplied by n, for example. So we think about this methodology in particular for an SDN environment. So, and to make the performance monitoring more flexible. So next. The flow classification. As also Tal mentioned in a previous presentation, we see that we can identify the flow we want to monitor with some identification fields. For example, for an AP flow, we need the IP source, IP destination, transport protocol, source port, destination port, and class of service, if you want to make a class of service based performance monitoring. And to create the flow with alternate marking method, you have to identify your flow that have to be a point-to-point flow, because you have to recognize your flow along your path, and your counter has to be coherence along your path. With multi-point alternate marking, you can enable the performance monitoring without any constraint about the identification field. So the kind of flow that you can monitor in next slide are very general. So point to multi-point, multi-point to point flow, and also in general multi-point to multi-point flow. Next. How multi-point marking operates? The first thing is we have to build a graph. So we have our production network. We have to identify our nodes of the graph that are the monitoring points, the measurement points, and the link between these measurement points. That could be real or also virtual. And then we build our monitored network graph that was composed by input, ingress, measurement point, the egress measurement points, and the intermediate measurement points. Next. For this monitored network, we can define the network packet loss. So this is always true, the packet loss property, that packet loss of this monitored network is the sum of the input packets minus the sum of all the output packets for all output measurement points. So this is a very simple rule, and we have the formula. But this rule is just general for all these multi-point network. Next slide, we can see how we can recognize the cluster within our monitored network, and we can define the cluster that is the smallest subnetwork maintaining the packet loss property for each subnetwork. So we can say that for every complex network, for every multi-point to multi-point flow, we can always recognize these smallest subnetworks that have this packet loss property. This is also under the study of a collaboration with the university, that if we have this complex network, we can always recognize this cluster with the graph theory, some graph theory consideration and some algorithm that we can demonstrate and will be detailed in the next version of the draft. So, yeah, next. As well of the packet loss, this method can be applied also to the delay. This is the example of the mean delay. Okay, I can skip also this slide, but the methodology can be applied also in this scenario. So, just last words. Next. So the idea is that, for example, you can see the potentiality of this methodology, because if you think about an SDN-oriented network, a controller, for example, can calibrate performance measurement for all the network, then can, in case of problem, in case of packet loss, in case of high delay, can recognize the cluster and can detail with by changing the filter criteria of our flow, can recognize the cluster and make a per cluster or in case of needed, a more detailed per flow performance monitoring. So I suggest to also read the draft of Tal, and in the next version, our idea is to detail more about the cluster algorithm calculation and more detail about also the delay measurement.
Real quick, thank you, Giuseppe. Al Morton suggests to take a look at RFC 5644, which has some of the metrics I think you're trying now to define. It's for spatial and multi-party metrics.
Okay, thank you.
So I'm going to take the challenge and do this really quickly. My name is Tal Mizrahi, and this is joint work with Carmi, Giuseppe, Mauro, Mac, Vero, and Greg.
Where's the clicker?
Okay, so this draft has been around for a while, but it has a new title and a new scope. And basically, the new scope of this draft is it does two things. One is to define new alternate marking methods, which are compact. That is, they require either 1 bit per packet or 0 bits per packet. The other thing we do is we summarize all the existing and new methods for alternate marking. We compare the pros and cons and the trade-offs between them. And the idea is that if you're designing a network protocol and you're going to use alternate marking, for example, an MPLS, NSH, beer, you'll be able to use this comparison and trade-off to choose which alternate marking method is best for you. So I'm going to skip ahead now because of the short time. I'm going to skip to the summary. So this draft basically summarizes all the alternate marking methods, including the 2 new marking methods which are described here that use only a single bit, and some of the methods that use 0 bits per packet. Marvell is going to demo this week, actually tomorrow in the Bits and Bytes, a demo of alternate marking using multiplexed marking, 1 bit per packet. And actually, a very cool method is used there called time flip. So please come to our booth and see how it works. Now, basically, if you've read the alternate marking draft, which has passed working group last call recently, you should probably read this draft as well, and you should probably have an opinion about it. Even if you haven't read, actually, if you haven't read the alternate marking draft, you should definitely read this draft. And we do expect to get comments and feedback about this. Even comments like, this is not useful or this is not interesting, can also help us. So any feedback would be welcome here. Thank you.
Thank you very much. That concludes the IPPM meeting at IETF 99. We will see you in Singapore. Apologies to those on the lightning talk queue that we did not get to bring into queue. So thanks very much, and we'll see you on the list. Can you take care of all that? I need to run to a program meeting.